0, all engine running. We have a liftoff on Apollo 11.
Tranquility Base here. The Eagle has landed. Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're going to be busy for a minute.
Armstrong is on the moon. Neil Armstrong, 38-year-old American, standing on the surface of the moon. On this July 20th, 1969.
That's one small step for man, one giant leap for mankind.
Many people describe the 21st century as the age of technological advancement, with technology like cell phones, advanced AI, and laptops becoming common in many places, like at home, school, or at work. People overlook the event that led to some of the United States' greatest technological advancements that are either still used to this day or paved the way for future advancements, the Apollo 11 moon landing. Following the events of World War II, the fear of the spread of communism plagued the U.S. To contain it, the United States engaged in the Cold War, a long-lasting arms race with the Soviet Union. In 1957, the Soviet Union launched Sputnik, an artificial satellite. After this success, the United States entered the space race. The coup de grace of the space race on the United States front was the Apollo 11 mission, the first successful human-occupied landing on the moon, carried out by NASA, the National Aeronautics and Space Administration, on July 20th, 1969. It secured America's win in the space race and was the accumulation of work from chemists, engineers, welders, and mathematicians alike. NASA had sponsors from all over the United States to pull everything together piece by piece. The Apollo moon landing contributed to many technological innovations like computers, spacesuits, cameras, fly-by-wire, integrated circuits, and the impressive creation of the International Space Station. One of the major hurdles faced when sending man to the moon were the computers. Even the smallest computers at the time were comparable to multiple refrigerators, way too big to stuff in a rocket ship. NASA needed something smaller and much more compact. With the help of scientists from the Massachusetts Institute of Technology, NASA developed a flight computer relative to the size of a briefcase. On top of being years ahead of the game in size, the computer used was also leagues above the average computer in speed. At the time, computers used a punch card, a paper or cardboard slip inserted into the computer to give it instructions, which would not be viable for the mission. However, this newly developed computer required no such thing, instead using a fully functioning keyboard that would instantly confer information to the computer. Planning to use it on Apollo 11, they tested the new computer on Apollo 7 through 10 to ensure it would work. This newfound technology would go on to be the new standard when it came to smaller hardware and structured software. With that challenge overcome, NASA had to develop safe suits for the astronauts to survive the harsh conditions of space. These would have to keep the astronauts safe from extreme temperatures and radiation from the sun without the protection of Earth's atmosphere. The suit would need to keep the wearer safe from over 1,000 degrees Fahrenheit. At the same time, they would need to be flexible enough to maneuver in. For their expertise, the company Playtex was enlisted. At the time, Playtex was known for their bras and girdles. Each spacesuit was crafted with 21 layers of fabric. The layers were made up of materials like metallized polyester films, Teflon-coated glass microfibers, and neoprene rubber. Each of these layers were hand-sewn by women working for Playtex. Even the smallest mistake made while working on the suit would ruin it. A mistake as small as about 4/5 of a millimeter would lead to failure. To keep an astronaut alive in the spacesuit, they would need around 3.75 pounds per square inch of oxygen. When it came to pressurizing the suit, the engineers would need to allow the astronaut to maneuver freely. To overcome this issue, Playtex invented convolutes. Convolutes were nylon tricot reinforced neoprene. This allowed the astronauts to freely move their joints like their elbows, knees, ankles, hips, and more. They needed a spacesuit to maintain its shape and absorb force, so the suit was lined with steel aircraft cables for support. Finally, they would need the proper equipment to document the treacherous journey. The astronauts would need top-of-the-line cameras. The most important cameras taken on the trip were 3 Hasselblad 500 ELs. 2 of these cameras were used in previous Apollo missions. The first of the previously used cameras was stationed in the command module during the flight. The second, on the other hand, was placed in the lunar module. The third camera, which was taking its first journey to space, was a Hasselblad 500 EL data camera. This camera would be used on the moon's surface. This camera was different from the other two for many reasons. First, it included a Roseau plate, a device used to determine distance between objects in view. Next, the modified camera included a Zeiss lens, which was specifically designed for NASA. That lens would eventually become available commercially. The camera was also lined with silver to help protect it from variations in temperature. With these cameras, we were able to acquire amazing pictures of the moon and the Earth. After their use in the lunar landing, Zeiss lenses became a household name in the photography scene. They are not only used in household cameras for simple photos, but professional cameras to film shows and movies. Once all the complications were out of the way, Neil Armstrong, Buzz Aldrin, and Michael Collins were able to successfully take off. Neil Armstrong and Buzz Aldrin were sent to the surface of the moon via the lunar module dubbed Eagle, while Michael Collins was orbiting the moon in the command module dubbed Columbia. While it might have been exciting, they were not there for leisure. They had many tasks to complete on the moon. These tasks would further our knowledge of the moon and space alike. At around 110 hours after Apollo 11 was launched, Neil Armstrong took his first step on the moon, followed by Buzz Aldrin 20 minutes later. While there, they explored the moon and deployed a camera to send signals back to Earth. Other tasks included conducting a solar wind composition experiment, deploying a seismic experiment package, and other instrumental procedures. Finally, they were also to gather lunar samples and take extensive pictures. In total, they spent 21 hours and 36 minutes on the moon before launching back to Earth. The success of this mission led to great technological innovations in the USA and then the world. A piece of technology used by families on vacation and Air Force pilots alike is fly-by-wire. Fly-by-wire is a system found in most, if not all, current aircraft. It is a system that converts a pilot's controls into electronic signals. These signals are then transmitted to the plane's flight control computers, or FCC for short. Fly-by-wire also sends feedback to the pilot. Other advantages include being more fuel efficient, lighter, and sleeker. NASA's first fly-by-wire aircraft was the LLRV, the Lunar Landing Research Vehicle. This aircraft was used to decide piloting techniques for landing on the moon. Fly-by-wire was also implemented on the lunar module piloted by Neil Armstrong on the Apollo 11 mission. After the success of the Apollo 11 mission, NASA began to develop a way to implement fly-by-wire technology to commercial airlines all over the US. The first time fly-by-wire was used in a flight was May 25, 1972, piloted by Gary Creer. Fly-by-wire now powers flights all over the world. Another byproduct of the Apollo 11 mission is the widespread use of integrated circuits. Integrated circuits were smaller than anything else being used at the time, but there was no advantages of them being that small in the 1960s. While the integrated circuit already existed, the success of this previously untested technology led to engineers testing it in everyday appliances. Now they are being used in most current technologies, including, but not limited to, computers, smartwatches, televisions, and microwaves. The Apollo program used 60% of America's supply of microchips. The all-or-nothing gamble made in the development of the Apollo 11 rocket led to microchips being used all over the globe. Finally, by far the most impressive technology stemming from the Apollo 11 mission is the International Space Station, also known as the ISS. Thanks to the technology stemming from the Apollo 11 mission, we have been able to build an International Space Station spanning the length of a football field, with at least 7 concurrent astronauts always taking residence from 16 different countries ranging from the United States to Switzerland. The ISS has been occupied non-stop since November of 2000, swapping out astronauts every 6 months. Experiments in the ISS have led to breakthroughs like new water purification systems and responding faster to natural disasters, thanks to the gambit that was the Apollo 11 space launch. In summation, the Apollo 11 space launch was a huge turning point in technology. Many of the common technologies we see today are a result of this turning point in American history. It led to the development of older technology, the creation of new technology, the experimenting of untested technology, and fueled innovation all over the world. Without the Apollo 11 space launch, we would not have been where we are now for at least another decade or two.